So we also get some questions revolving around the first and second derivatives, and they're more practical applications. So for instance, question one. So you're given four curves, you have to comment on the first derivative and the second derivative. So we talk about increasing or decreasing, then their concavity. So the first derivative is greater than 0 because it's increasing, and it's concave up. So the second derivative is also bigger than 0. So a quick way of doing that is to fully do the turning point, and you'll see it's a concave up curve. Let's rub that out. Okay, the second one is decreasing. So the first derivative is going down, and it's concave down. So the second derivative is less than 0. Third one, first derivative is increasing, but the rate at which that is happening is decreasing. That's the way you say it. So it's, you can see, do it in red, it starts off high, a little steeper, and it flattens out. So if that was a population, the population is levelling out. And the last one, it's a decreasing curve, but it's concave up. Okay, next one. Question 2. The curve below shows a population of a colony of seals. Describe the sign of the first and second derivatives, and then in a sentence, how is the population rate changing? So it's always over time. This time increases from left to right, and this time we're talking about population. So A, the sign of the first and second derivatives. So like the last question. So is it increasing or decreasing? It's increasing over time. And is it a maximum or minimum if we were to complete it? Well, it's a maximum. Okay, and how is the population changing? Well, if you look at this, it's increasing, but the rate of that is slowing down. So the first derivative is the rate of change of y, and the second derivative is the rate of change of the first one. So we write the population is increasing at a decreasing rate. Population is increasing at a decreasing rate, and that word rate is important. Alright, question 3, we're required to draw a graph, and they give us the information that the inflation is increasing, but the rate of increase is slowing. So inflation is increasing means the first derivative is bigger than 0, but the second derivative, the rate of that first derivative, is slowing down, decreasing, less than 0 or a maximum. So we draw a graph, and it's over time. We're talking about I, inflation, and we just put these two things together. So it's an increasing curve, but it's the part, it's the concave down. So it's increasing, but it's concave down. So something like that. Okay? And then just check it is true. It is increasing, and it is a concave down curve. Okay, a similar question. The size of classes at a local TAFE college is decreasing, and the rate is also decreasing. So the first derivative is less than 0, and the second derivative is also less than 0, so it's a maximum. Then draw a curve, time, and we'll go class size. So it's decreasing on a maximum, which is that part, something like that. Okay. Okay, and this one, they give you the graph and they want you to describe it. So the graph shows the number of students in a high school over several years. Describe how the school population is changing over time and include the rate of change, or include the word rate at least. So if we do our two indicators, the first derivative is less than 0 because the curve is decreasing. And the second derivative, well, if we finish this curve out, it's a maximum. So I'll rub that out. So the second derivative is also less than 0. Now that's not describing it, that's describing it using mathematical indicators. But if we want to write a sentence, like in an exam to be 1 mark, describe how it's changing over time. The population is decreasing at a decreasing rate. So they're always the same every time, increasing or decreasing, and what sort of rate that is. So finally, to sum up, this is the table that we looked at in class, and we're just going to go through each box. So a curve that is increasing and minimum looks like that. A curve that is decreasing and minimum is the other part of the minimum. And a curve where the first derivative is 0, so a stationary point, and the second derivative is bigger than 0 is a minimum. And it's that point there. Okay. Next one, increasing concave down. Decreasing concave down. Stationary point, concave down. And lastly, increasing, and the second derivative is equal to 0. Is something like this. Point there. That's where your change of concavity occurs for the second derivative to be equal to 0, but it's increasing. Decreasing is the opposite way. So it's the halfway point between turning points, if you want to look at it like that. And lastly, if the first derivative and the second derivative is 0, then you've got a horizontal point of inflection, which may look like that, or it may be going down. Okay, it's a point of inflection. And they're the only possibilities.